In this video we will talk about the UDP as one of the protocols of the transport layer. The transport layer provides a flow control, reliability, and congestion avoidance. The most common examples for protocols on the transport layer are TCP and UDP. Both TCP and UDP travel encapsulated into a layer 3 protocol such as IP. In that video we will concentrate on the UDP or user datagram protocol. Because we deal with stacked protocols, UDP, or layer 4 packets travel inside IP, or layer 3 packets. UDP stands for User Datagram Protocol, is the easiest of the transport layer protocols. UDP has a protocol number 17, this is the value on the IPv4 packet structure. Do you remember it from our previous video? In IPv6 the field is called next header and used equally. It was first introduced in 1980, however it is not the oldest transport protocol. TCP, that we will see next, is even older. Let's have a look at the UDP header. The UDP header looks very simple, it's just for fields, each of them 16 bits long. The length field, that informs about the total length of the UDP header plus the payload. Then next field is the checksum, which is optional for IPv4 because it already has a checksum field. It's required for IPv6. Then we have two port fields, a source port, which is optional, if it's not used, set to 0, and the destination port. Let's explain now the port numbers. Just imagine an UDP packet as a parcel to be delivered to a large apartment building with several post boxes, one for each apartment. Port numbers act as the apartment number to inform the postman to which apartment the UDP parcel has to be delivered. In networking we do not have a buildings, however we do have a computer systems with software running on top of it. The networking software, sometimes called daemon, listens to some specific port numbers for incoming UDP packets to be delivered to the appropriated applications, our apartments. When using UDP, the sender does not know if, and when the packet has arrived. So the sender just sends UDP packets. So UDP is used for types of communication where it doesn't matter if a packet gets lost on the network and is not properly delivered. So, in what sort of applications is UDP useful? Let's put one example, the Network Time Protocol, or NTP. It is used for synchronizing clocks over the internet, so computers send and receive packets with a timestamp in it. If one packet gets lost, well there will be another one in just a few milliseconds or even less. So it is not dramatic to lose one or more UDP NTP packets, right? Another example is the DHCP, a dynamic host configuration protocol. It is widely used in IPv4 networks to allocate proper IPv4 addresses to computers temporarily. It works like this: your computer, one set on, broadcasts a request for an IPv4 address. Then, a server receives this UDP packet, and sends back an UDP packet and tells you the IP address and other parameters you can use to get connected. To sum up, the User Datagram Protocol, UDP, is a connectionless protocol on the transport layer. UDP packets are also called datagrams. The UDP header contains a source and a destination port number. UDP is used when we do not need to confirm the reception of the data at receiver, so is very useful in the Network Time Protocol and Dynamic Host Configuration Protocol. Thanks again and see you on next videos.